Okay, so looking at this, again, looking at adding and subtracting, very similar kind of setup at the beginning as the last two class periods. Okay, we're going to work these very, very basic, simple problems. If you want to do these on the half sheet, you can. All the other problems that we're going to go through, you will have to do it on a separate sheet of paper. There is no way that you'll be able to fit it on there. So, somebody tell me why adding and subtracting is probably, for most people, more difficult than multiplying and dividing. Not greatest common factor, but a common denominator. So the bottom has to be the same. Bottom of the fraction has to be the same. If you already have a common denominator, that makes these extremely easy. Okay, a lot easier than they are if there's not. Okay, that's kind of what we're going to go through first through A, B, C, and D. But looking up here, obviously this first one has 5s as a common denominator. So 4/5 minus 1/5 is going to give me what? 3/5. Your denominator will stay the same. Okay. Going to the second one, I got 2/3 plus 1/2. A lot of you can probably tell me that the common denominator would need to be 6. Again, I'm going to do this kind of a weird way, but that's kind of how we're going to look at it whenever we get down here. Okay, so to identify the common denominator, and anytime you hear me write CD, that's what I mean, common denominator. So what I'm going to do is I'm going to go through the denominators of all the fractions, and I'm essentially just going to list them over here. So on this problem, I've got 3, and I've got 2. So my common denominator is 3 times 2. Which I get it, it's 6, but just stick with me here. So now I'm going to go, that's what I call identifying the common denominator, and then I need to apply it. So I'm going to put it into both these fractions. So if the first fraction is 2 times 3, what part of the common denominator is this missing? 2. The 2. So I'm going to multiply the top and the bottom by 2. No, do not cross multiply. That has nothing to do with this lesson. Okay? On the second fraction. Okay, so on the second fraction, which is 1/2, what is that denominator missing? 3. Okay, so now my denominator is going to be the same. Okay, and I'm still going to write it as 2 times 3 right here. And then I'm going to take what I have in the numerator. So what is 2 times 2? 4. It's an addition problem. What is 1 times 3?
3.
4 times 3, 4 plus 3 is what?
7.
7. But then I am going to eventually need to put it in its most simplified form. So I'm going to multiply the denominator out. So looking at this, and I know this is going to seem weird, I'm going to write this because a lot of times what you'll need to do, especially whenever we get here, is you're going to have to factor this. Okay? You're going to have to factor wherever you can, just like the last 2 class periods we talked about. So I'm actually, and I'm not going to rewrite it, you can visualize this. I'm going to look at that 14 as 7 times 2. Okay? So my common denominator on this is going to be 7 times 2. Okay? They both have 7s, but this one has a 2 over there. So whenever I apply my common denominator, do I have to do anything to this second fraction? No, it's already set up. It's good to go. So I'm going to have that as 1 over 7 times 2. What is the first fraction missing? Times 2.
Teachers and students, as a reminder, we are in lock out, not lock down. You may continue teaching. No one is to leave the classroom.
That's funny because you know what happened. That's what that means. There are a bunch of classes where everybody was crammed up. Okay. All right, what's 2 times 2? 4. And the second fraction, I just had 1. So I can do 4 plus 1, which is 5. 7 times 2, which is 14. Okay, so let's go to this first section. It's kind of broken up into 2. So these examples, it says perform the indicated operation, simplify the result, leave answers in factored form. Okay. So all of these are going to have common denominators. They've already got them, and this is what makes this easy. It's not going to get real hard till we get to the second part, but there's some small things in here you need to make sure you pay attention to. At the end of the problems, don't let this confuse you. We've already given you the excluded value. If it's not there, then you will need to find it. All right, but today we're just kind of focusing on just the adding and subtracting part of this. So, on A, both denominators are the same. So I know that the denominator in my answer needs to be 2x squared minus 7. Okay. So I've got my denominator. So I'm going to take the first numerator. This is an addition problem. And I'm adding negative 3x minus 8. Okay, go ahead and write the parentheses in there. And I'm going to talk about when you especially need it and when you may not necessarily have to write it in there. Okay, but if I take this, so I've combined them. Now I need to simplify my numerator. Is that plus sign, if I distribute it in, is that going to change anything over there? Yes. No. If I distribute a plus, it's not going to do anything. So I'm going to end up with 6 minus 3x minus 8 over 2x squared minus 7. After that, I've got 6 minus 8, which is going to give me negative 2.
Would it be negative 3?
Yes, ma'am. Thank you. So now I look at this, and once you have it combined and once you have it simplified, you have to sometimes, well, I'll say not sometimes, every time you need to look to see if you can simplify it, because once you get it down to one fraction, if you can factor it and cancel something out, then you need to. Okay? But on this one, we can't factor negative 3x minus 2. We can't factor 2x squared minus 7. So this, along with the excluded values, which you would include that in your answer as well, is the answer to this one. Okay, so again, this is a little bit easier than what we're about to see because you don't have to find the common denominator. Okay, I want you to attempt B. Okay, this is what you should have gotten up here. We'll kind of walk through it and take questions. So, common denominator is x plus 2. So I know that's going to be in my answer. After that, I have the numerator from the first fraction plus the numerator of the second fraction. And then once I have that set up as one fraction, I simplified my numerator. Can I cancel x plus 2 here? No. This is x plus 2. That is 9x plus 2. If it was this, Could I cancel the x plus 2's? Yes, because on top I have a 9 and an x plus 2. So I could cancel it then. Okay, there's a big difference between 9x plus 2 and just x plus 2. Okay, and that's one of the probably one of the difficult things just about this whole unit. That's not specific to today. That's stuff we've seen this whole time. So let's go down to C and D. So again, still common denominator, so nothing is changing there. So I've got 14x squared minus 9. So again, now I'm going to take the numerator of my first fraction minus parentheses negative 3x squared plus 5. Is that going to affect the numerator of the second fraction? Yes, this is the most commonly missed, this is the most common mistake that I've seen in the past, is people don't do that. They may make the 3x squared positive, but they won't distribute it to that second term. Okay, that's where the mistakes happen. So whenever I go through simplifying this, I have 9x squared plus 3. I'm going to distribute that negative, so I've got plus 3x squared minus 5. Then I will simplify it further, so I've got 9 plus 3, which is 12. 3 minus 5, which is negative 2. And then I've got 14x squared minus 9. Can I simplify anything there? What can I do in the numerator? Okay. So I've got the greatest common factor of greatest common factor of 2, which leaves me with 6x squared minus 1. Can I factor the denominator? No. Okay, now look up here. I don't want this to confuse you as I work through some more examples here in a minute. But because a lot of times problems may have a few more steps to it. But if you noticed, and I don't like to waste time if I don't have to, I wrote 14x squared minus 9 4 times up here. Okay? Here in a minute, one of our common denominators is going to look something like that. It's going to have 3 binomials with x plus or minus a number in it, okay? So if I'm doing a problem and that's my common denominator, I don't want to have to write that 7 times. Okay? I'm not going to write it 7 times. So what you'll see me do a lot is once I know I have my common denominator identified, instead of writing the same thing over and over again, you're going to see me write CD down there as I go throughout the problem. Now, whenever I write my final answer, I need to write it. I don't need to write CD there, okay? I need to write what it actually is. So if you want to practice that on this next one, even though this is just x squared, it's not that hard to write it. But go ahead and attempt D, and you'll see me using that shorthand on the next section of the notes. Alright, moving on to this next section of the notes. Okay, so make sure that you're paying attention because this is where it gets a little difficult. I've already talked about it. The difficulty, in my opinion, is being able to identify what the common denominator needs to be. And you'll see why people struggle with that here in a minute. Okay, so again, you've got different denominators. So the first thing you'll need to do is check to see if you can factor. Anything you can factor, you need to factor. Then create a common denominator. So, looking at this first problem, and I'm going to try to show you a method in identifying the common denominator. Hopefully it will help you, and hopefully it won't mess you up anymore. So, first, can I factor any of that? No, 1's prime, 5's prime, 2's prime, then you got just x and x. So, I need to identify what my common denominator needs to be. And to do that, now this one's pretty simple, but to do that, you're going to go through both denominators, and you're essentially just going to list all the different factors that are in there. Okay, so going through there, what all do we have in the denominator? So I got 2 and x. Do I need to list the other x? No. Okay? And if you need to, because a lot of people will do that, and technically you can, it's going to make the problem a lot harder than it has to be. But you've got the 2 in there. Whenever you mark off that x, if there's an x in the other denominator, you can mark it out so that you don't include it as well in the common denominator. So next I need to apply the common denominator. The first fraction. Do I need to do anything to the first fraction? No. Do I need to do anything to the second fraction? Yes. What is it missing? I need to multiply both the numerator and the denominator by 2.
So to find the common denominator, you're just multiplying the...
Okay, so now I've got my common denominator of 2x. And then my numerator, I've got 1. This is an addition problem. And 10. Which 1 plus 10 is what?
11.
And then the excluded value is given up there. And then on F, you'll kind of start to see why identifying the common denominator can be a little tricky at times. Okay, so my common denominator. I'm going to go through all of the denominators. So first thing I run into is 5.
Do not count the x.
Okay, so in the other denominator, I also have 5, correct? So do I need to have both 5s in my common denominator? No. Next thing I come across is x.
Do not put x after 5.
Okay? And the other denominator, is there just an x? No, that is x minus 4. That's kind of the confusing part. Well, there's an x over there. No, it's a binomial. It has that minus 4 has to go with it. Okay? So I've got that x accounted for, and now I've also got to include the x minus 4. Okay, that's a good question. Last time, whenever we were dealing with multiplication, I meant to mention this at the beginning. Whenever you're eliminating stuff and you're adding and subtracting, if this was multiplication, we would be able to cancel, if anything's in the if I have something in the numerator, wherever, I can cancel it if it's anywhere in the denominator. Whenever you're dealing with addition and subtraction, you have got to just look within each fraction. You've got to take it one fraction at a time. All right, so if you didn't hear Sutton, he asked if, okay, can I cancel out those x minus 4s? And the answer to that is no, because they're in two different fractions. Okay? Thank you for asking that. All right, so now I've got it identified. Now I need to apply it. So I have,
So that's the common.
that's going to be the common denominator, 5x times x minus 4. So whenever I look at my first fraction, what is it missing? What's the denominator missing?
X minus 4.
X minus 4.
It's missing.
Yep.
But it is X minus 4.
Okay. So now I go to my second fraction. What is the second fraction missing? The x. Just the x. So I'm gonna go ahead and put it in the spot where it would go. So we have identified the common denominator, we've applied the common denominator, and now I'm going to bring it all together. Okay, it is going to be over. Okay, there's that shorthand. That's all that means. I don't want to have to rewrite 5x times x minus 4 6 more times. I'm just going to write common denominator. So I've got x times 4 times x times 4. I'm going to go ahead and multiply that and write that in. Okay, you may just have to trust me here. That's going to give me x squared minus 8x plus 16. Okay, that's FOIL, box, however you do that.
Wait. What?
Okay,
It's the ABC.
then it's a subtraction problem. So now, because it's a subtraction problem, I normally put parentheses around the second numerator. Why on this problem do I not necessarily have to?
It's just
Just what?
it's just one. It's just positive.
It's just one. Well, it's just one term.
Yeah.
Okay. If it was 12x plus 4, you need to write the parentheses because you're going to mess it up if you don't. If it's just one term, then you don't need the parentheses because you're just going to distribute it in and it's going to give you that. So now I've got that. I need to simplify. So I've got x squared. I have negative 8x minus 12x, which is going to give me negative 20x. And then I've got plus 16 over 5x times x minus 4. Can I factor the numerator?
Yeah.
Okay, what factors of 16 add up to negative 20? Okay, so if no one's figured it out so far, what might that tell you? You can't factor it.
Do you find, how would you factor that if you could?
All right, let's do G. Go ahead and get the problem written down. What is my common denominator going to be? Say that again, L. There you go. Just going across my denominators and listing the factors. So now I go to the first fraction. Is the first fraction missing anything? missing x plus 5. Is my second fraction missing anything?
Minus 3.
X minus 3. So after that, I'm going to start to add my numerators. So the first one I can distribute that 1 in there, which is not going to do anything. So I'm going to end up with x plus 5. This is an addition problem. Distribute that 2 in. So I've got 2x minus 6 over my common denominator. And then I'll just simplify my numerator. So 3x minus 1 over x plus 5, x minus 6. Sorry, x minus 3. Can I factor anything here? No.
Wait, so.
Is it okay if I
Okay? If you're good on that, I want you to go ahead and attempt H. Okay? Make sure you're using that as your common denominator. Do I need to make any changes to my first fraction? What do I need to add to my second fraction? Alright, so that's what you should have gotten down there at the bottom, the 3 times. X plus 12 over x plus 8 over x minus 3. Alright, okay, let's go to I. So, go ahead and write that down for me. So, Alex Shirley, what would the common denominator be? All of it.
X plus 1, x minus 2, x plus 3.
Okay. Nick Miller, what is the first fraction missing? X plus 3. This is the one that I was referring to earlier where I'm not going to write that whole denominator over and over and over and over again. You can, but I'm not. So looking at the second fraction. Preston, what is the denominator missing on it? X minus 2. So now I've got 2. I'm going to go ahead and distribute the 2. Okay, so as I do this, that would be 2x plus 6. It's an addition problem. And then I would have 3x minus 6. All over my common denominator. I'll combine my like terms. So that's going to give me just 5x up top. And then now I've got x plus 1, x minus 2, x plus 3.
Does the denominator have to be in that same order?
No. Are you saying like if you were to switch x minus 2 and x plus 1, yeah, it's the same thing. Yes, the order of these don't matter. All right, once you got that written down, go ahead and go to the next one. I'm going to get you started, and then I want you to finish it. Okay, on this last problem, what do I need to do first? No, not simplify, but factor. Okay, and if you did not see it, that's fine, because this is the first problem that we've had where the first step is to factor. So my first fraction is fine. Then I've got minus x minus 3, and then if you were to factor that down there, you would end up with x plus 2 times x plus 2. Okay, so now let's identify what the common denominator would be. Okay, I got an x plus 2. Is that it?
No, x plus 2.
I need 2 of them. Okay, so look at this. And this is why early in the notes, whenever I kind of showed you that method of crossing them out. So if I go along the denominators right here, I've got that first x plus 2. That only takes care of one of these over here. Okay? I still have to account for that second x plus 2 in my common denominator. So now that you know what the common denominator needs to be, I want you to finish this problem. From this point on, it's not very difficult.
Do you have like a thing that you guys to get an arrow on the iPad? Are you just that good at drawing arrows?
Wait, minus x.
Because that's going to turn into negative.
second one.
So wait, so why wouldn't you distribute that? Oh, okay.
Is x squared its own x code?
Okay, so to get to the x squared minus 4, that came from these two right here.
Yes.
X minus 2 times x plus 2. It is a subtraction problem. And then I've got my x minus 3 right there. So now, going along to that next step, I distributed the negative. So that's going to give me negative x plus 3, which is down here. And then I just simplified my numerator. And do not forget to actually write out your common denominator in the bottom. Okay, so the homework is on the bottom part. The extra practice is on the bottom part of that half sheet. It's set up the same. On the back, you're going to have all the answers to that. Next class, what we'll be talking about is we will be talking about solving these kind of equations. And I will not be there on Thursday as well. Okay, so make sure that you know that, and you'll have another video. If you need help, you need to come in and see me during power lunch sometime this week. Okay.